Welcome back, dear students. Today we are starting a very interesting chapter, and the name of the chapter is Heights and Distance. So before we start doing the problems, here we should know the concept of trigonometry. That's what I want to say at the beginning itself. Okay, now since we have already done trigonometry in our class 9 and in class 10 also, let's understand a new topic now. Okay, so after assuming that you have or we are familiar with the trigonometry, let's understand the new concept of angle here. Okay, so here we are going to learn about three different concepts. First is called angle of inclination. Okay, so let's understand what is inclination, angle of inclination first. Okay, so before we understand angle of inclination, what we are going to do is we will first draw a horizontal line, as you can see. So this is your horizontal line, this is, and another we will draw is vertical line. So when you draw horizontal and vertical, this angle formed, remember this angle formed will always be 90 degree. So this is going to be 90 degree. Now from the definition, angle of inclination will be formed between the vertical or horizontal as defined by the situation. Okay, so angle formed with the vertical line or horizontal line is called the angle of inclination. For example, in the diagram, see there is a chair, you can see. So this chair is making an angle of 42 degree with the vertical, isn't it? So this angle is given to be 42 degree. So that means chair is inclined with vertical line but not with the horizontal line. Is that clear? So this is called angle of inclination. Okay, so this is defined by the situation. Now very important concept is angle of elevation. So whenever there is something called angle of elevation, what you need to remember is it is formed by looking up from the horizontal. Okay, so again we have horizontal and vertical. So if you're looking up, okay, so see there's a person who is looking up, so the angle formed by this is called line of sight. By the way, this is called line of sight because you are looking up, isn't it? So if the angle between the line of sight and the horizontal line is there, so this particular angle is called the angle of elevation, right? Okay, now this is all about angle of elevation. Now what is angle of depression? Let's understand that. So angle of depression, this is also very important, is formed by looking down from the horizontal. Suppose there's a tower and you are standing up there. Okay, so if you are standing up here and if you are looking down, then this is called your line of sight in this case. Okay, so this is your line of sight. So the angle formed by the line of sight and the horizontal by looking down is called angle of depression. For example, in this case this angle is given to be 23 degree, so that's why the angle of depression here is 23 degree. Okay, so this is all about angle of inclination, elevation and depression. Okay, now one thing that I want to mention here is, suppose let's say if I draw a horizontal line from here. Okay, now if you observe this, diagram, this angle and this angle, they will be same. You know why? Because they are alternate angles. Okay, so if they are alternate angles, they must be equal. Okay, so you need to keep this thing in mind. So basically this becomes angle of elevation, isn't it? So angle of elevation and angle of depression both gives you the same value. All right, so you need to keep this thing in mind, and as I have already told you, you must be knowing the trigonometric values also. Okay, at standard angles. Okay, and if you don't know, don't worry. If you don't know the trigonometric values of standard angles, don't worry. In examinations, you will be provided with the log table where you can find the trigonometric values also. Okay, so I assume that you know how to make use of the trigonometric table. Okay, so with that assumption, let's see the first question for the day from exercise 22A. Question says, the height of a tree is root 3 times the length of its shadow. Find the length of the elevation, find the angle of elevation of the sun. Okay, so in order to understand this particular problem, what am I going to do is I'll quickly draw the respective diagram. So let's say there's a ground. So this is your ground, okay, and on this ground, on this ground there is a tree. Okay, so there's a tree on the ground. Okay, so this blue line represents the tree. Okay, now since they are talking about the shadow, its shadow will be exactly on the ground, isn't it? So let me say that this green colored will be the shadow. Okay, I'm sorry, not the shadow. So suppose if there is a sun out here, okay, if there is a sun out here, so there's a sun here, you can see. So if there is a sun, then your shadow will be somewhere over here. So what am I going to do here is I'll just write down the names. So here this AB represents the tree and BC represents the length of shadow. Okay, now obviously the observer will be somewhere over here. He observes the sun in this way, isn't it? So that's why your angle of elevation in this case, okay, so angle of elevation in this case is this one. Okay, and let me call this angle to be angle theta. So that's what the question is asking us to find. Okay, so let me write down the solution of this. So let AB and BC represent the height. Okay, so AB is the height of the tree, isn't it? So AB is the height of the tree. And what is BC? BC is the length of the shadow and length of the shadow respectively. Length of the shadow respectively. Okay, so I have written down the necessary thing. Okay, now one more thing that you need to remember is, remember the angle between the tree and the ground. Okay, so you can write tree out here and you can write ground out here. Okay, so the angle between the tree and the ground will be 90 degree. So if this is 90 degree, side opposite to this will be my what? It will be my hypotenuse, isn't it? Now the angle is theta here, so side opposite to this, that is this perpendicular, this tree becomes my perpendicular as it is opposite to the given angle theta. Rest over part is my base. Okay, so we know all these things about our trigonometry, isn't it? Okay, now we have yet another thing to remember, that is the height of the tree is root 3 times the length of the shadow. Okay, now according to question, so we have according to question, height of the tree. What is height of the tree, by the way? AB is the height of the tree. So AB is given to be root 3 times length of its shadow. Root 3 times shadow is how much? Shadow is BC, isn't it? So it is root 3 times BC. Now what am I going to do is I take this BC to the denominator. Okay, so you are left with root 3. Now AB is what? AB is the perpendicular. What is BC? BC is base. So basically this is P by B, and you know P by B is turned permanently black, that is tan, isn't it? So that's why this is tan theta equals to root 3. Now from the trigonometric table, all of you know that root 3 is nothing but tan 60 degrees, isn't it? It is tan 60 degree. So therefore what is theta? if you see here, tan theta is equal to tan 60 degree. So that's why if you compare both sides, you find that the value of theta will be how much? It will be exactly 60 degree. So this will be my answer for this particular question. Alright, so you may pause the video and note down your solution. Let's take another question. So here question says, a ladder is placed along a wall such that its upper end is resting. Its upper end is resting against the vertical wall. Okay, so here what am I going to do is, I'll just draw the ground and the vertical wall. Okay, so we have, so this is, let's say this is my ground. Okay, and let's say this is my wall. Okay, so this is my wall and this is my ground, and here what you are going, you're resting a ladder on the wall. Okay, so let's say that this is my ladder. So this is my ladder here. Okay, so question is saying a ladder is placed along the vertical wall such that its upper end is resting against the wall. So this is my upper end. The foot of the ladder is 2.4 meter from the wall. Okay, so just look at this. Question is saying this is the foot of the ladder, obviously, right? So foot of the ladder is 2.4 meter from the ground, from the wall. So this is your wall. So foot of the ladder is this one. So basically this distance is given to be 2.4 meter. Okay, now, and the ladder is making an angle of 68 degree with the ground. So this is my ground, so this is my ladder, so that's why it makes an angle of 68 degree as per the question. Okay, now find the height up to which the ladder reaches. So you need to find the height of the wall where the ladder touches, the top of the ladder touches. Okay, so that's what you need to find. So for that, what am I going to do is, I'll just first name it. So let me call the triangle formed to be triangle ABC, where you see angle B is 90 degree. Okay, now let me write the solution. So here let AB and BC, so basically here we have to make use of AB and BC only here. So let AB and BC represents, now what does AB represent? AB represents the height of the wall, isn't it? Represents the height of the wall where the ladder touches. And what does BC represent? BC represents the distance between the wall, and foot of the ladder. Okay, so these are things that you need to mention. This is how you need to mention. Okay, now in triangle ABC, okay, so in triangle ABC the given angle is 68 degree. Okay, and remember this is your side opposite to given angle, so that's why this is my perpendicular. Side opposite to 90 degree, this is my hypotenuse, and this one, remaining one, is my base. Okay, now if you look at this, triangle, we have to make use of these two triangles. Okay, so we know, we'll make use of the sides which has to be like which is asked here and which is given here. So which is asked here, perpendicular is asked, you have to find perpendicular, and what is given? This is given, base is given. So perpendicular and base means we have to make use of tan again. Okay, so we know that P by B, okay, P by B is, or let's not write P by B, it will be better if I write AB by BC. Okay, so AB by BC is perpendicular base, which is tan theta, but here the value of theta is given to be 68 degree. Remember this. Okay, what is AB? Is AB given? No, so just write AB as it is. What is BC? BC is given to be 2.4 here. is equals to, now we have tan 68 degree. Now we don't know the value of tan 68 degrees. So for that, what you are going to do is you will go to the log table. Okay, so I cannot show my log table here, so you will go to the log table which is provided in the book. Okay, so since you are finding tan, you will go to the log table of natural tangents. Okay, so in natural tangents you will be able to find this. So it is given that tan 68 degree, okay, tan 68 degree from the table is given to be, from the log table it is given to be 2.4751. okay, so this is the value of tan 68 degree, right? So now let's do the cross multiplication. So we have AB equals to, so 2.4 into, so this is 2.4751. okay, so you just need to multiply here now. So 2.4 into 2.4751 gives you approximate, I'll just write down the approximate value. Okay, so the approximate value will be equals to, this is the sign of approximation, remember, it will be around 5.9. okay, so therefore we say if AB is 5.9, so that's why we say the required height, okay, the required height, that is, what is required here, the required height is height of the wall, is equals to AB, right? So AB is 5.9, and what is the unit being used? Unit being used here is meter. So that's why this will be my answer for this particular question, right? So pause the video and note down your solution.